An object moving along horizontal x direction with kinetic energy 10 joules. So what is the kinetic energy? Initial kinetic energy.
10 joules.
So object has this kinetic energy 10 joules, which is displaced through x equal to 3I. Means in the x direction it is moved up to 3 meter. And how much force is applied on that object? Minus 2I plus 3J Newton. The kinetic energy of the object at the end of the displacement x is. You have to find the kinetic energy at the end of the displacement, means final kinetic energy you need to find. Okay, so you have to find the final kinetic energy. So here kf value you need to find. So they have given x distance and f is a force, right? So by using the work energy theorem we can solve this question. Okay, what is the formula for work energy theorem? Work done equal to change in kinetic energy. All of you say work done equal to
Change in kinetic energy.
So work done means W, yes or no? Work done equal to W, that is uh, work done equal to change in kinetic energy, that is delta K dot E. Okay. Now what is the formula for the work? Force into distance. All of you say what is the formula for work?
Force into distance.
Force is F, yes or no? Into distance X, F dot X. Okay, F dot X equal to change in kinetic energy. Change in kinetic energy, how will you calculate? Final minus initial. Final we can write as Kf minus initial, right? What is the force vector we have here? Minus 2I plus 3J newtons, right? And the distance value is, what is the distance value? 3I meter equal to Kf minus Ki value is how much? Initial kinetic energy here given. How much it is? 10 joules. Okay. Now while multiplying this dot product, you have to multiply with I, J with J. Okay. So here I is there. So you multiply with this I cap. So I dot I value is 1. So minus 2 into 3 is how much? Minus 6. Is there any J term in the X?
No.
No. So you need not to consider. If there is no J term, means that is a 0. 3 into 0 is 0 only. Need not to take that. So Kf minus 10. Minus 10 when you take it here, this side, it will become plus 10. All of you please interact with me. If minus 10 when you take it this side, it will become plus 10. So 10 minus 6 equal to final kinetic energy. Then final kinetic energy is equal to 4 joules. So what is your answer? Your answer C is matching. Is it clear everyone? The potential energy of long spring when stretched by 2 cm is U. If the spring is stretched by 8 cm, what is the potential stored in it? So let us say there is a potential. So when you stretch the string up to 2 cm, let us say the potential energy is U. Okay. Suppose when you stretch the spring up to 8 cm, you have to find the potential energy U2, right? So what is the formula for this? What is the relation between the U and this X? What is the formula? U equal to half K X square. U equal to 1 by 2 K X square. Where K we call as spring constant. So U equal to, what is the formula? All of you say U equal to 1 by 2. That means this U potential energy is directly proportional to X square. U is directly proportional to what? X square. From this we can derive the relation U1 by U2 is equal to x1 by x2, x1 square by x2 square. Listen. So what is U1 we assumed here? U1 is already given in the question. What is the U1? U1, this is U. U1 value is how much? U1 value is U. U1 value is U. And what is U2? That is you need to find here. U2, which is equal to x1. X1 value is how much?
2
X1 value is how much? 2 centimeter. Okay. So that is 2 x square is there. So that is 2 square by x2. X2 is how much? 8 centimeter. So x2 square is there. So we can write as 8 square. 8 square. Is it clear everyone? Yes or no? Now 2 square is how much?
4.
8 square is how much?
4 by 64.
4 by 64. How many times it is? 16. Then U by U2 equal to 1 by 16. You do the cross multiplication. U into 16,
16
16 U. U2 into 1, U2. Then therefore the potential energy is how much? 16 times of initial potential energy. U2 equal to 16 U. Which answer is matching here?
Option
C.
C.
Option C is matching. Is it clear, everyone?
Yes, sir.
At any instant of time t, the displacement of any particle is given by 2 into t minus 1 under the influence of force of 5 Newton. The value of instantaneous power is in SI unit. You have to find out. Now you see, they given some displacement, right? Displacement of particle they given in the form of function in t, that is 2t minus 1. Let us say the displacement x equal to 2t minus 1. Okay, you find the velocity and use the formula p equal to f dot v. Okay, from this equation you find the velocity first, right? Velocity equal to distance by time, right? Dx by dt. Distance by time is velocity, right? So d by dt of 2 into t minus 1, how much it is? And when you derive the t, you will get the 1. When you derive the constant, you will get the 0. So d by dt of 2t is 2 into 1 minus 0. So this is equal to v equal to 2 meter per second, right? Already they given f value, how much they given? Force is how much? Force is how much?
5 Newton.
5 Newton. So F is 5 Newton and we got now 2. So 5 into 2 is how much? 10 watts. How much the power? P equal to 10 watts. So your option, which one is matching?
A.
Option A is matching, right? A particle moves with a velocity 5I minus 3J plus 6K meter per second. This is the velocity. Horizontally under the action of constant force F Newton, that is 10I plus 10J plus 20K Newton. We have to find the instantaneous power supplied to the particle E. Okay, then how do you find this? So we have the formula power equal to F dot V. Power equal to F dot V. This is the dot product of force and velocity vector. Okay, force vector and velocity vector. What is the force vector we have here? 5I minus 3J plus 6K dot 10I plus 10J plus 20K. Okay, while doing dot product, you multiply with I dot I value is 1. Okay, then what is 5 into 10 is? 5 into 10 is, let me say 5 into 10 is 50. Here. So 10I into 5I. So I dot I value is 1. 10 5 is 50. 10J into minus 3J. J dot J is 1. 10 into minus 3 is? J dot J value is 1. Okay, don't say J. So 10 into minus 3 is minus 30. Now K dot K value is 1. So 20 into 6. How much it is? 20 into 6 is 120. 50 minus 30 is how much? 20 plus 120. 140 watts. Okay, so what is the answer? Answer D here matching, right? An electric lift with a maximum load of 2000 kg, lift plus passengers, is moving up with a constant speed of 1.5 meter per second. Okay, this is a lift. What is the weight of the lift? 2000 kg and it is moving constant velocity with 1.5 meter per second. If it is moving with constant velocity means acceleration value is 0. Okay, and the frictional force opposing the motion is 3000 Newton. So one force because of the air resistor force also, because some force is resistor force is opposing this motion. That is how much resistor force is applying on this lift? 3000 Newton. So how much force is coming from the upward direction? 3000 Newton. And what is the weight? What is the what is the weight of this lift acting downward direction? That is m into g. Mg. How much it is? M into g is 2000 into 10. How much force is acting in downward direction? 20,000 Newton. Right? And this 20,000 Newton plus 3,000 Newton acting downward direction. To overcome this weight, it has to give 23,000 Newton in upward direction. Okay, the lift has to give how much force to move upward direction? 20,000 plus 3,000. So 23,000 Newton it has to give in upward direction to move constant velocity. Why? Because of lift and passenger, some force acting downward direction, that is 20,000 Newton, and some frictional force also opposing this motion. How much frictional force is opposing this motion? 3,000 Newton, and this is also acting in downward direction. Okay, to overcome this 20,000 and 3,000, that is 23,000, and lift has to give how much force in upward direction? 23,000 Newton. It has to give in upward direction to move the constant speed. Okay, and the total force it has to give how much? That is F equal to 23,000 Newton. So why? Because you have to add this 20,000 plus 3,000. Then you will get the total force. And this velocity given how much? It is moving with constant speed. That is how much? 1.5 meter per second. What we need to find the minimum power delivered by the motor to the lift it in watts is. So you have to find P. P equal to question mark. So how will you find this? P equal to formula? P equal to F dot V. What is F? 23,000 into 1.5. So when you calculate this, you will get, so 1.5 can I write 3 by 2? 2 1 2, 2 1 2, and 2 5 10, and this is 0 0. Okay, so this is 3 0 0, 3 5 15, 3 1 3. Sorry. 4 3 4. Okay, 34,500 watts. 500 watts. So your answer? Which one is matching?
C.
Option C is matching. So this is your answer. Option C. The energy that will be ideally radiated. The energy that will be ideally radiated by 100 kilowatt transmitted in 1 hour is. Okay, you change the 100 kilowatt into watts, right? So what is the power? So this is a formula to find out the energy. Energy equal to power into time. So power you converted into watts. 100 kilowatts. Can I write 100 into 1000 watts? Yes or no? Can I write like this? 100 into 1000 watts. And time is how much? 1 hour. 1 hour can I write 3600 seconds? Yes or no? 1 hour equal to how many seconds? 3600 seconds. Okay, now you use this formula and find out the answer. Energy equal to power into time. What is the power? How many zeros are there here? Here 3 zeros, here 2 zeros. Total 10 to the power of 5 watts. 10 power 5 into 3600. 3600 can I write as 36 into 10 square? Yes or no? So 36, here 5 tens are there, here 2 tens are there. Total how many tens? 7. So 10 power 7. So energy equal to 36 into 10 power 7 joules. Okay, so option A is